Today we got a super difficult SAT problem. Now, I'm gonna be frank with you, the concepts for this problem is just basic geometry. Like, no, there's 180 degrees in a triangle, but the setup is what tricks so many students. So pause the video and try and solve the problem on your own. And yeah, this is also super time consuming, as you'll see later on. You know, on the SAT, time is of essence. So it says two angles in the isosceles triangle measure x plus 5 degrees and 2x minus 30 degrees. Compute the sum of all the possible vertex angles of the triangle. Okay, so when we see isosceles triangle, what do we know? Well, we know in the isosceles triangle you have two base angles which are equivalent, and we get two angles right here. But the only thing or caveat for this question is that there are multiple combinations, right? So not only are we going to set these two expressions equal to each other, but we need to find all possible vertex angles, all possible combinations of base angles as well. So I'll show you what I mean. So first off, let's just consider the first scenario. So our first scenario is if x plus 5 degrees equals 2x minus 30 degrees. Now, why is this? Well, this is when we are considering both of these to be base angles, right? And we know base angles of isosceles triangles are equivalent, and therefore we can set these two expressions equivalent to find the value of x, which you'll see later is super helpful to solve for the vertex angle, the first possible vertex angle. So in this is just simple algebra, right? So let's just subtract. Honestly, no, let's add 30 on both sides. So I'm just going to skip a step. So we add 30 on both sides, and then we subtract x on this side. So then we get 35 equals x, right? Just super simple algebra. So we get x equals 35. Now, what do we do from here? Well, now we want to find the actual value of the base angles, because we just found x, but x doesn't really mean anything until we use one of these equations. Now, since we know that these are equivalent, we can just pick and choose, right? I'm just going to use the first one because it's super simple. So 35, we're just substituting that in for x plus 5 will give us 40 degrees. So now we have found the value of the base angle, right, for this particular scenario. So that's 40 degrees. We know there are two base angles, so 40 times 2 is 80 degrees, and we know there are 180 degrees in a triangle. So if we do 180 minus 80 degrees, the 40 times 2, we'll find the angle measure of the last angle, which is our vertex angle. So that's 180 minus 80 degrees is 100 degrees. So that is the value of the first possible scenario, but there are two other scenarios we need to consider. Okay, let's move on. So scenario 2. Scenario 2 is when both base angles are the value of x plus 5 degrees, and in that case, 2x minus 30 would be our vertex angle, right? So this is what it looks like. So if we have we're going to have two, because x plus 5 is our base angle, we're going to have two of those angles, right? So we're going to do 2 multiplied by x plus 5, and then let's just label that degrees. In this case, we're also going to add on that 2x minus 30 degrees. And I'm going to put parentheses just so we don't get confused. Equals, and I'm going to set this equal to 180 degrees. Now why? Well, this part of our equation, those are the two base angles. This part of the equation is our supposed vertex angle. That's three angles. And we know, a triangle has three angles, and those angles add up to 180 degrees, okay? So now, basic algebra. So 2 times x gives us 2x, 2 times 5, 10, plus 2x minus 30 equals 180, oops. Okay, so now we're gonna add 30 on both sides and subtract 10 on both sides. That's gonna be 160, boom, that's 4x. So x in our case, oh wait, I just screwed up my algebra, oops. If we add 30, that's 210, and if we subtract 10, that's 200, sorry. We all make mistakes, guys. So that's 4x, oops. It's not even letting me right. Okay, so x in our case would be 50. Now, what do we do with this value of 50? Well, like before, we have to plug it in, right? So the question is, we can't plug it into just any part of our expression, right? If we plugged it into the base angle, that doesn't really help us because that doesn't find our vertex angle. We're trying to find all possible vertex angles of the triangle. I mean, you could technically, but that's just one extra step for no extra reason. We need to find that 2x minus 30 degrees is our vertex or supposed vertex angle. So we just take this expression, 2 And then for the x, just substitute in the 50 that we saw for. So then 2 times 50 minus 30, so that's 100 minus 30 is equal to 70 degrees. And that is our, if I can circle this properly, that is our second possible vertex angle value. Now it's time to consider the last possible combination, which is going to be, of course, if the base angles are 2x minus 30 degrees. Okay, so very similar to number 2 now, we're just going to do 2 times 2x minus 30 degrees. Boom. And then we're going to add on our supposed vertex angle now, because we have one last angle left of, this is really not letting me write today. Okay, x plus 5 degrees. And just like the other problem, we set it equal to 180 degrees. Okay, so now what is this? 4x minus 60. Oh boy. And then plus x plus 5. I'm going to save myself some writing and skip some algebra steps. So mental math. 180 plus 60, that's 240, that's 235. And then we have 4x plus x, what is that, 5x? So that would be, let's see, so that's x equals 47. Okay, cool. So x equals 47. Now, like we talked about before, we got to use that supposed vertex angle. So our supposed vertex angle in this case is x plus 5. So 47 plus 5 gives us a final answer of 52 degrees. So that's our third and final possible vertex angle. So now the question asks for the sum of all possible vertex angles of the triangle. So 100 plus 70, that's 170. 170 plus 52 is 222 degrees as our final answer. You guys subscribe to our free weekly newsletter. We're going to be dropping tips every single week on how to score 1500 plus on your SAT. But alongside that, we're going to have curated lists of opportunities like summer programs, extracurriculars, all that mumbo jumbo. So if you want access to that, make sure you click the first link in the description. But enough of that. Let's get into the question. So it says square sides are increased by 37%, resulting in an area that is equal to that of a rectangle with a 2 to 5 side length ratio in a perimeter of 24 units. Find the area of the original square and round your answer to the nearest 10th. So there's a lot to unpack here. The first thing I'm going to do is focus on this first part. The square sides are increased by 37%. When we see a percent increase, we're going to use the formula 1 plus r over 100. In this case, r is just going to be our 37, right? So if we have 1 plus 37 over 100, we get 1.37. This serves as our scale factor, right? So we can apply the scale factor to the side length of the square to find the length of the new side. So let's say we represent the original square side as s, right? And so then we can just apply this 1.37 to the front as the coefficient, and now we have the new side length of our new square, right? But the problem says in the next part, resulting in an area that is equal to that of a rectangle. So the area of the new square is equal to the rectangle's area. And so to find the area of a square, we just do, side times side, and all the sides of a rectangle, all the sides of a square are the same length, so we can just square this value. And when we set this equal to the area of the rectangle, which we do not know, but right, so what we can do here is actually set up a systems of equations because this is a fixed ratio, right? So then we can write this as 2x plus 5x. And what we're essentially going to do is solve for x by setting this entire equation or expression equal to the perimeter, because once we're able to find x, then we're able to actually find the length and width, multiply those together, and then set that equal to the squares area, if you can see where we're going. So I'll explain this. So we have 2x. What does this represent? Well, if you think about a rectangle has two sides, the width and the length. So in this case, the shorter side, 2, is going to be the width. So this is the width, and pretend this is the length, right? And then we're going to set this entire thing equal to the perimeter, which is 24 units. But what is the perimeter? The perimeter is the sum of all the sides of a rectangle. We only have one width and one length right now, and so we need to multiply the entire thing by 2. There we go, and now we can just multiply everything out to solve for x. So we get 4x plus 10x. Oops, okay, just pretend that's 10x equals 24. So that's 14x equals 24, and so x must equal 24 over 14. So what do we do with this value of 24 over 14? Well, pretty simple. We plug it into 2x and we plug it into 5x to solve for the actual value of the width and the length. So we have the value of our width and length, right? So what do you do from here? Well, we need to find the area of the rectangle, right? So we can set it equal to the area of the square. So we just multiply these two fractions together and simplify that, and we get a value of 1,440 all over 49. All right, cool. So now we just have to solve for s squared because we're trying to find the area of the original square. And so because s represents the original side length, then we want to find s squared because that's side times side equals the area of the original square. So this right here expression, 1.37 squared, that's kind of, 1.37s squared is the same thing as 1.37 squared times s squared equals 1,040 over 49. So I'm going to save a couple steps, divide both sides by 1.37 squared, and then we have our answer. So in this case, s squared is equal to approximately 15.65, and you got a bunch of decimals after that, but we want to round to the nearest tenth, and therefore our answer in this case, s squared, will be equivalent to 15.7 as our final answer. Which of the following represents the x-intercept of the graph of y equals f of x plus 9 in the xy plane where d is a constant? All right, guys, so this is the same deal. All you have to do is know how to use Desmos, right? So the first thing I did over here is you can see I just plugged this equation, the entire thing right into Desmos, and it plugged it right here, right? We get the x-intercept, but that's not what we want to find. You have to interpret the question. It says, which of the following represents the x-intercept of this f of x plus 9? So there's a transformation. So all we have to do here is, after setting the slider for d, which I just set as 1, so it didn't really impact the equation, all you have to do really is just write f of x plus 9, right? That's a transformation they described and applied it right here. This red line right here is going to be that x-intercept. And so you can click on it and it tells you the exact x-intercept. And so now we know that's going to be negative 1.2667. So go back to your answer choices, and we know we set d equal to 1. So all we have to do here is pretty much just guess and check, right? So we plug in 1 for d in all of our choices, and we see we actually lucky out here. The first choice here is going to be negative 126 times d is 1 minus 26 over 120 will give us that value of negative 1.2667, which lines up with our x-intercept over here. And therefore, we can pretty confidently say that R is similar to a question from Blue Book practice test number 7. It says a right circular cone has a slant height of 97 centimeters, and the area of its base is 5,329 pi square centimeters. What is the volume of the cone in cubic centimeters? Okay, let me switch colors here. Okay, so what is the first plan of action? Well, we're given a couple things. We're given the slant height. So you might be wondering, what is the slant height? Well, I have a nice diagram here. You can see, oh god, green does not show up well there. I'm changing my colors to pink. So this right here, this L labeled is the slant height. Okay, so your actual height is this, right? H, that is just the actual height. But your slant height is referring to this value out here. You'll recognize that the slant height actually makes a right triangle with the height and the radius. And so we're going to utilize that to find a couple values in the future. But the first thing I want to do is actually find the radius, right? Because currently we don't know the radius, but it's pretty easy to find. So the base area, which is given, is equivalent to the pi times r squared. So what is the base area? Well, it's given right here as 5,329 times pi square centimeters. So 5,329 pi equals pi r squared. So r squared. So now, how do we find r? Well, we just isolate and solve for r. So in this case, r will be equivalent to 73 centimeters. Always have your units just to be cool. All right, so now we can actually utilize this right triangle, I guess, relationship. So we know the, oh god, I have to change back to pink. So we know the radius, right? Our radius here is 73. Our height is a unknown, so that's what we're trying to solve for. And we know our slant height is given as 97, and we referred to the slant height as just this L right here. So that is 97. So now we can use the Pythagorean theorem, a squared plus b squared equals c squared. So let's set that up. So if you want to write this as an expression, it'd be length equals r squared plus h squared. So this is not actually the length, that's the slant height. But we know the slant height, which is 97. So 97 squared equals, I guess if we take the square root, we should then I squared this side. So r, let's make that 73 squared plus height squared. All right, so if we subtract 73 squared from 97 squared and take the square root of both sides, we're going to get the height, height equals square root of 4,080, which gives us 64 centimeters as the height. Okay, so now we have the radius and now we have the height. What do we do from here? Well, we just use one last formula, which is the volume of the cone. So the volume of a cone is equivalent to 1/3 times pi r squared times height. And so now it's pretty easy to find the volume because we know the radius, which we found, and we know the height, which we found here. So 1/3 times pi times r, which is 73, square that times h, the height, 64. Oh boy, it's starting to look like some weird symbols over here, but all this is going to be approximately equal to 113,685.333 pi. And so we get a decimal of the answer choices we have. It lines up pretty nicely with answer choice C. And so that is our answer for that one. All right, let's move on to the next question. So this one is similar to a Blue Book practice question from the practice test 10. This one's pretty interesting. It says the triangles ABC and XYZ are graphed in the XY plane. Triangle ABC has vertices AB and C at 3, 2, 3, 6, and 7, 2. Respectively, triangle XYZ has vertices at XYZ at 3, 2, 3, 6 plus M and 7 plus M2, respectively, where M is a positive constant. If the measure of angle B is S degrees, what is the measure of angle Z? Oh boy, a lot of variables going here. So let's just, draw diagrams. The diagrams really help us solve problems. So all these coordinates right here are on the positive XY plane. So like the first quadrant. So let's say this is our plane, and then 3, 2 is like right there. So that's A. And then 3, 6, I don't know, it's like up here somewhere. We don't need to be totally accurate because we just need to recognize a pattern, right? And the 7, 2 is like out here, aligned with A. Okay, not C. So we make a nice right triangle, okay? So what do we need to find, right? Well, this is actually interesting because you'll see that A, the coordinates of A are 3, 2. So I should probably label that 3, 2. Coordinates of B are 3, 6, 3, 6. And so we can actually find the side length of the triangle. So from 3, 2 to 3, 6, that's an increase of 4 units. That's a side length of 4. And then C here is 7, 2. And so the side length of this side is also 4 because 7 minus 3 is 4. And so, interesting enough, we have a isosceles triangle. Okay, so we have a right triangle, right? Because these lines line, I don't know what to call it, AB and AC, they're perpendicular. And so we can call these both angles 45 degrees. And funnily enough, it says if the measure of angle B is S degrees, blah, 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 what is the measure of angle Z? Well, we just found the measure of angle B, 45 degrees. So 45 degrees must be equal to S. But that's just only one variable because we have to find angle Z in terms of S or M, which I don't know if we can find. But let's do the same thing that we just did for all this mumbo jumbo for XYZ. So triangle XYZ looks like it's the same coordinates except there's a variable. So we have 3, 2. So let's call it X, 3, 2. And then we're going to have 3. So it's on the same Y plane thing. And then 6 plus M. Okay, so that's interesting. So we don't actually know where the Y value is. So I'm just going to place it somewhere. Let's call it there.
call this 3, 6 plus m. And the reason I'm doing this is because there's another relationship, as you'll see later. So then we have the last coordinate is 7 plus m, 2. So very similar to this last coordinate as well. So it's somewhere out here. So that's 7, plus m, comma 2. And so we make another right triangle. We don't actually know the length of it because we don't know the length or the value of m. But what we can do is find a relationship because m is existent in both of these side lengths, right? So if we were to find the side length of this right here, what would that be? Well, it would be 4 plus m. So I'm going to erase this, 4, because when we went from 3 to 6 plus m, if you add 4 plus m to that, you get 6 plus m. So 4 plus m is our side length there. And we get the exact same thing for this side length, which is also 4 plus m. Because 2 plus 4 plus, if you have 3 plus 4 plus m, wait, that's hard to say. 3 plus 4 plus m equals 7 plus m. There we go. And so because these two side lengths are equal, we have another isosceles triangle. So this, we talked about before, perpendicular lines, 90 degrees. This must be 45. This must be 45. And so, what is this? Blah, 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 respectively, where m is a positive constant. Okay, so m is a positive constant. That makes sense in that case. What is the measure of angle z? What is z? So z looks like is the third coordinate, so it is this one right here. So what is the angle of that? Well, we just labeled it as 45 degrees, right? So 45 degrees. And so which one of these answer choices gives us 45 degrees? We know s is 45 degrees. And so we just plug in 45 for s in one of these answer choices and get the answer. Well, we don't know what m is, right? We don't know what that is. But in answer choice C, we got 90 minus s. S is 45. 90 minus 45 is 45. We know z is 45. So C happens to be our answer again.